Suppose that the limit as x tends towards a of f of x is k and the limit as x tends towards a of g of x is L. We are going to prove that the limit as x tends towards a of the sum of these two functions, f of x plus g of x, is the sum of the limits, k plus L. Now, we choose an epsilon from the outset. It is some positive number. Next, we use the fact that the limit as x tends towards a of f of x equals k. That means that given any epsilon 1, which is some positive number, actually we will choose epsilon 1 to be our epsilon divided by 2. Since epsilon is a positive number, obviously epsilon divided by 2 will be greater than 0. Anyway, for some epsilon 1, there exists a delta 1, such that whenever x is within a distance delta 1 of a, but not equal to a, in other words the magnitude of x minus a is greater than 0, then f of x is within a distance epsilon 1 of k. Now, since the limit as x tends towards a of g of x is equal to L, we know that given any epsilon 2 greater than 0, we will choose epsilon 2 equal to epsilon over 2. There exists a delta 2 greater than 0, such that whenever x is within a distance delta 2 of a, but x is not equal to a, then g of x is within a distance epsilon 2 of L. Now let delta be the minimum of the two deltas, delta 1 and delta 2. We are interested in the magnitude of this quantity here because we want to prove this limit. So we want to show that the limit as x tends towards a of f of x plus g of x equals k plus L. So we want the difference between, or the distance between f of x plus g of x and k plus L. Well, we can write it like this, and then we can apply the triangle inequality to write it like this. And that's how we can use the results of the other two limits. Now suppose that x is within a distance delta of a. Since delta is the minimum of delta 1 and delta 2, then obviously delta itself is going to be less than or equal to delta 1. That means the magnitude of x minus a is going to be less than delta 1. But if that's the case, from up here we know that f of x is going to be within a distance epsilon 1 of k, where epsilon 1 is equal to epsilon over 2. Similarly, since delta is the minimum of delta 1 and delta 2, obviously delta is going to be less than or equal to delta 2. In other words, the magnitude of x minus a is going to be less than delta 2. But from up here, we know that that means that g of x is going to be within a distance epsilon 2 over L, where epsilon 2 is equal to epsilon over 2. So this gives us epsilon. So you see that if we choose any epsilon greater than 0 from the outset, then we can find a delta, such that whenever x is within a distance delta of a, but x is not equal to a, then f of x plus g of x is within a distance epsilon of k plus L. In other words, the limit as x tends towards a of f of x plus g of x equals k plus L. Now what about the limit as x tends towards a of the difference of these two functions, f of x minus g of x? Well, we can write f of x minus g of x like this and apply the result for the sum of two functions. This time the two functions are f of x and minus g of x. So our second function now is minus g of x. But minus g of x can be written as minus 1 times g of x. Now we can apply the result from a previous video. The limit as x tends towards a of a constant times g of x is that constant k times the limit as x tends towards a of g of x. We just make the constant equal to minus 1. So we can take this minus 1 in front here, so we get minus 1 times the limit, or minus lim as x tends towards a of g of x. So we see that the limit of a difference of two functions is the difference of the limits of the two functions.